Hello, viewers. In this session, we are going to discuss another important problem from three-dimensional geometry related to finding out the shortest distance between two non-coplanar lines. Right. So here we have this problem where we are given two lines. The equations of the two lines are given in symmetric form. X minus 3 over 1 is equal to y minus 5 over minus 2 equal to z minus 7 over 1, and the second line is x plus 1 over 7 equal to y plus 1 over minus 6 is equal to z plus 1 over minus 1. And here we have to find out the shortest distance between these two non-coplanar lines, and in addition to this we have to find out the equation of the line of shortest distance and the coordinates of the point where the line of shortest distance meet the given lines, right? So let us see how we can find out the shortest distance between these two lines without using any formula, right, except the distance formula, that is the distance between 2 points, right? So here we'll find out the shortest distance between these two lines using the distance formula. So let us start. So now let us first draw a rough diagram for this problem, and here let us denote this line as L1 and this line as L2, right? So here these two lines are lying on different planes, right? So here we have the line say L1, and here we have the line say L2, and these two lines are lying on two different planes. That's why they are non-coplanar, right? And the shortest distance between these two lines L1 and L2 is the this segment which is perpendicular to both the lines L1 and L2, right? So the shortest distance is the line segment joining the two lines L1 and L2, and this is line of shortest distance which is perpendicular to both the lines L1 and L2. And let us take this point as a point A, which is the point of intersection of the line L1 with this line of shortest distance, and let us take this point as point B, which is the point of intersection of the line L2 with this line of shortest distance. So here AB is our line of shortest distance, and A and B are the points of intersection of the line L1 and L2 with the line of shortest distance, and AB is perpendicular to L1, and AB is also perpendicular to L2. So here we are taking this line as L1, this line as L2, and now let us take two scalars, that is say lambda, and here we can take the scalar mu to find out the coordinates of this point A and the point B, right? So to get the coordinates of the point A, let us take the line L1. So here the line L1 is x minus 3 over 1, y minus 5 over minus 2, z minus 7 over 1 is equal to lambda. Now to get the coordinates of this point A, which is the point of intersection of line L1 with this line of shortest distance AB, let us now here find out the values of x, y, and z in terms of lambda. So we have x minus 3 over 1 is equal to lambda, y minus 5 over minus 2 is equal to lambda, and z minus 7 over 1 is equal to lambda. So from here we have x minus 3 is equal to lambda. Then from here y minus 5 is equal to minus 2 2 lambda, and from here z is equal to, uh, here we can write z minus 7 is equal to 1 times lambda, that is lambda. So from here we can write x is equal to lambda plus 3. From here we have y is equal to minus 2 lambda plus 5, and from here we have z is equal to lambda plus 7, right? So for some value of lambda, we have the coordinates of this point A, as here we have lambda plus 3, which is x, then we have minus 2 lambda plus 5, which is y, and then we have here lambda plus 7 as a z. Similarly, we can find out the coordinates of the point B from the equation of the line L2. So we have x plus 1 over 7 is equal to y plus 1 over minus 6. Z plus 1 over minus 1 is equal to mu. So let us again form three equations here, that is x plus 1 over 7 is equal to mu, y plus 1 over minus 6 is equal to mu, and z plus 1 over minus 1 is equal to mu. So from here we have x is equal to 7 mu, and here we have minus 1, and here we have minus 6 times mu, and then we can take plus 1 to the right hand side. So we have minus 1, and from here we have minus mu and minus 1, right? So for some value of this scalar mu, we have the coordinates of the point B as 7 mu minus 1, then we have minus 6 mu minus 1, and then we have minus mu minus 1, right? So for some value of lambda and mu, we have the coordinates of the point A and point B, and once we know the values of lambda and mu, we can easily find out the coordinates of the point A and B, and then by making use of the distance formula, we can easily find out the distance AB, which is our shortest distance, right? So let us take the coordinates A as x1, y1, and z1, and let us take the coordinates B as x2, y2, and z2. So now let us make use of the concept of perpendicular lines. So here AB, the line of shortest distance, is perpendicular to L1, and the line of shortest distance AB is perpendicular to L2, right? So if we have the direction ratios of the line of shortest distance, that is AB, as say A, B, and C, right? So let us consider the direction ratios of the line of shortest distance AB as A, B, and C, and we can easily find out the direction ratios of the line of shortest distance by simply subtracting the two coordinates, right? So A can be given by x2 minus x1, B can be given by y2 minus y1, and C can be given by z2 minus z1. So the direction ratios of AB are given by x2 minus x1, y2 minus y1, and z2 minus z1, because we know that when we have 2 points on a given line, then we can find out the direction ratios by subtracting the two coordinates, right? So here x2, y2, z2 are given by these three numbers for some value of mu, and x1, y1, z1 are given by these three numbers for some value of lambda. So now we have the direction ratios of AB as A is x2 minus x1. So we have 7 mu minus 1 minus lambda minus 3. B is given by minus 6 mu minus 1. Then we have plus, here we have negative sign. So we have plus 2 lambda minus 5. And then C is given by minus mu minus 1, and then we have minus lambda and minus 7. So here we have 7 mu minus lambda, then we have here minus 4, minus 1 minus 3 is minus 4. Here we have minus 6 mu plus 2 lambda, then we have minus 6, and here we have minus mu minus lambda and minus 8, right? So the direction ratios of AB, the line of shortest distance, are given by 7 mu minus lambda minus 4, and then we have minus 6 mu plus 2 lambda minus 6, and here we have minus mu minus lambda minus 8. So now let us write the direction ratios of the line L1, right? So the direction ratios of this line L1 are given by these three numbers, that is 1, minus 2 and 1, and the direction ratios of L2 are given by these three numbers, that is 7 minus 6 and minus 1, right? So let us now make use of these two conditions, that is first is AB is perpendicular to L1, right? So when two lines or two vectors are perpendicular, then the dot product of the two vectors, that is the direction ratios of this line of shortest distance AB as A, B, and C with this vector, that is the direction ratios of the line L1, which are 1 minus 2 and 1, it should be equal to 0, right? And similarly, when we apply this condition, that is AB is perpendicular to L2, then the dot product of the vector, that is AB, which is given by A, B, and C with this vector, that is 7 minus 6 minus 1, the dot product should be equal to 0, because we know that if two vectors or two lines are perpendicular, then the condition for the perpendicularity of two lines or two vectors is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. That is the dot product of a1 b1 c1 with a2 b2 c2 is equal to 0, right? So here we have applied this concept, right? And here the line L1 is parallel to the vector which is given by 1 minus 2 and 1, and L2 is parallel to the vector, that is 7 minus 6 and minus 1. So let us now form two equations using these two. Here we have two equations, right? So here A, B, C are given by these three numbers. So we have now 7 mu minus lambda minus 4, then we have minus 6 mu plus 2 lambda minus 6, and minus mu minus lambda minus 8 with this vector 1 minus 2 and 1 is equal to 0. So we have 7 mu minus lambda minus 4 times 1, then we have minus 6 mu plus 2 lambda minus 6 with minus 2, then we have minus mu minus lambda minus 8 with 1 is equal to 0. So let us solve it. So we have 7 mu minus lambda minus 4. Here we have plus 12 mu, and then we have minus 4 lambda plus 12, and then here we have minus mu minus lambda minus 8 is equal to 0. So now let us simplify this expression. So here we have 12 plus 7, 19. 19 minus mu is here 19 mu minus mu is 18 mu. And then here we have minus lambda minus 4 lambda and minus lambda. So here we have minus 6 lambda, and then we have here minus 4 and 12 and minus 8. So minus 4 and minus 8 is minus 12, and this is cancelled with this 12, right? So we have simply here 18 mu minus 16 lambda is equal to 0, right? So now let us take the dot product of these two vectors. So when AB is perpendicular to L2, we have the dot product of these two vectors is equal to 0. So A, B, C are given by these three numbers, and here we have this vector 7 minus 6 and minus 1, and this is equal to 0. So now we have 7 mu minus lambda minus 4 times 7. Then we have minus 6 mu plus 2 lambda minus 6 with minus 6. So here we have the product of these two numbers. And then we have minus mu minus lambda minus 8 times minus 1 is equal to 0. So now here we have 49 mu minus 7 lambda minus 28, and here we have plus 36 mu minus 12 lambda, then we have plus 36, and here we have plus mu, and then we have plus lambda, and here we have plus 8 is equal to 0. Now here we have, so now here we have 49, here we have 36, and here we have 1. So 49 plus 36 plus 1 is 86 mu. And here we have minus 7 minus 12, and here we have 1. So this is minus 18 lambda, and then we have minus 28 plus 36 is equal to 8, and here we have plus 8. So here we have plus 16 is equal to 0, right? So now here we have 86 mu minus 18 lambda plus 16 is equal to 0. So we have the second equation in mu and lambda, and here we can take this 16 to the right hand side. So we have minus 16. So this is our second equation, right? So now from these two conditions, we have obtained two linear equations in mu and lambda, and we can now easily solve these two equations by the usual methods. So here we can now solve these two equations by the method of elimination. So now let us multiply equation 3 with 3. So here we have 3 times 18 is 54 mu. Then here we have minus 18 lambda is equal to 0. And the second equation is 86 mu minus 18 lambda is equal to minus 16. So here we can see that the coefficients of lambda in both the equations are now minus 18 and minus 18. So let us now subtract this equation from this one. So here we have the negative sign, here we have positive sign, and here we have a positive sign. So 54 minus 86 is minus 32 mu, and here these two terms get cancelled, and here we have plus 16. So mu is equal to 16 over minus 32, that is equal to minus half, right? So now let us substitute mu is equal to minus half in this equation. So we have 18 times minus half, then we have minus 6 lambda is equal to 0. So here we have 9. So we have minus 9 minus 6 lambda is equal to 0, taking minus 9 to the right hand side. So we have here plus 9, and lambda is 9 over minus 6. So here we have 3, and here we have 2. So the value of lambda is minus 3 over 2. So we have now obtained the values of mu and lambda as a minus half and minus 3 over 2, and using these two values we can easily find out the coordinates of the points A and B. So now taking lambda is equal to minus 3 by 2 in this coordinate. So the coordinates of the point A are given by minus 3 by 2 plus 3. Then we have minus 2 times minus 3 over 2 plus 5. Then we have minus 3 over 2 plus 7, and here we can now write minus 3 plus 6 over 2. Here 2 and 2 get cancelled, and this is plus 3, and here we have plus 5, and here we have minus 3 plus 14 over 2. So we have now 6 minus 3 is 3, that is 3 over 2, this is 8, and here 14 minus 3 is 11. So we have 11 over 2. So these are the coordinates of the point A, and to get the coordinates of the point B, let us take mu is equal to minus half in this coordinate. So we have minus 7 over 2, then we have minus 1, then we have minus 6 times minus half minus 1, then we have minus half, and then we have minus 1. So taking mu is equal to minus half in this coordinate. So we have now here minus 7 minus 2 over 2. Here we have 2 times 3 is 6. So this is plus 3. Negative times negative is positive. And then we have here plus half and minus 1. So we have now minus 9 over 2. 3 minus 1 is 2, and here we have half minus 1 is minus half. So the coordinates of the point B are given by minus 9 by 2 comma 2 comma minus half. So here we have now obtained the coordinates of the point where the line of shortest distance meet the two given lines L1 and L2. So A and B are the 2 points where the line of shortest distance meet the line L1 and L2, and the coordinates of the point A are given by 3 over 2 comma 8 comma 11 over 2, and the coordinates of the point B are given by minus 9 by 2, 2, and minus half. So now let us obtain the direction ratios of AB. So the direction ratios of AB, which is our line of shortest distance, are given by simply subtracting these two coordinates. So we have here x2 minus x1, that is x2 minus x1 is given by minus 9 over 2 and minus 3 over 2, that is minus 12 over 2, that is minus 6. And then we have y2 minus y1, and here we have 2, then we have minus 8, and this is minus 6. And then we have z2 minus z1, and z2 is minus half. Then we have z1 is 11 over 2. So here we have minus 1 minus 11 is minus 12, and here we have 2, so we have minus 6. So x2 minus x1 is minus 6, y2 minus y1 is minus 6, and z2 minus z1 is also minus 6. So here we have minus 6 and minus 6, right? And here if we write these direction ratios in reduced form or simplified form, then we can write the direction ratios of AB as 1, 1, and 1, that is dividing throughout by a negative 6. So now let us find out the shortest distance, and the shortest distance is now given by the distance formula, that is x2 minus x1 square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, because now we know the coordinates of the point A and B. So here we have x2 minus x1 as minus 6. So we have minus 6 square. Then we have y2 minus y1 as minus 6. And then we have z2 minus z1 as minus 6. So here we have now minus 6 square is 36. Here we have 36, here we have 36. So now we have here 36 plus 36 is 72, and then we have here 108, right? So we can now write square root of 108 as 36 times 3. So here we have the square root of 36 as 6. So we have 6 times square root of 3, right? So the shortest distance between these two non-coplanar lines is given by 6 times the square root of 3 units. And this is how we can find out the shortest distance. Now let us find out the equation of this line of shortest distance, that is AB. So now the symmetric form of the equation of line of shortest distance AB can be obtained by using the symmetric form x minus x1 over A, y minus y1 over B is equal to z minus z1 over C, where A, B, C are the direction ratios of AB, and the direction ratios are given by 1, 1, and 1, and x1, y1, z1 may be taken as this point A. So the equation of line of shortest distance AB is given by x minus x1. X1 is 3 over 2, and then A is 1, and then we have y minus y1. Y1 is 8, and here we have B is 1. Then we have Z minus Z1. Z1 is 11 over 2, and C is 1. So this is the required equation of the line of shortest distance AB in symmetric form, that is in this form. right? And we can also find out the equation of line of shortest distance AB if we use this point, that is point B. So in this case, we can write the equation as x minus, here we can now take the point as x2, y2 and z2. So we have x minus x2 over a, y minus y2 over b, and z minus z2 over c. So we have now the equation of shortest distance as x minus x2. X2 is minus 9 over 2. So here we have already a negative sign, so this becomes positive. So we have 9 over 2 over 1. A is 1, b is 1, and c is 1. Then we have y minus y2. So here we have y2 as 2, and here we have 1. Then we have z minus z2. Z2 is negative half, so this becomes positive, and here we have 1, right? So the equation of the line of shortest distance AB can be written like this, or it may be written like this. So this equation is formed using this point A, and this equation is formed using this point, that is point B. So this is how we can find out the equation of line of shortest distance.